Thank you for coming out. This is Build Your Own MVVM Framework. My name is Rob Eisenberg. I'm a consultant at Blue Spire. We focus primarily on user interface architecture design, primarily in the Silverlight and WPF space, and now Windows Phone 7 series. You can follow me on Twitter. Eisenberg Effect is my Twitter handle. So as I said just a couple of minutes ago, this is kind of an intermediate MVVM talk. So if you're not familiar with at least the basics of that pattern, or if you didn't just attend Lawrence's talk on the subject, we'll be going at about light speed, all right? And even if you are familiar, we're going to be going pretty quickly through a lot of stuff. What I did for this talk, actually, is build a sample application. And I tried to remove as much of the plumbing as I could from the MVVM pattern and push it down into a little framework. So this is not a talk about using someone else's framework. This is a talk about what you can do to build sort of a little bit of infrastructure for yourselves to make the whole process of MVVM much easier for you. So just as a basic starting point here, just to review real quickly, and I'm not going to spend a whole lot of time here. The pattern is model, view, view model, also known as MVVM or presentation model. The interesting part, of course, is the view model part. Everybody's probably pretty familiar with what a model is. This is your business logic classes. This is maybe your messages or your web service calls. We know that a view is the thing that we see on the screen, and it's when we get to that view model part that things get a little bit weird, and we're not quite sure what the heck that thing is. So, the simple definition of this is that it is a model designed for the view. It supports the view by supplying state, properties, and actions that are specific to what the user is doing with the application. This is different from a model because the model is optimized for the business logic, for the rules, and all these sorts of things. The view model is optimized to power the user experience. And there are oftentimes aspects of state that have nothing to do with the business logic, but that have everything to do with what the user is doing at a given point in time. For example, take Visual Studio. You have your Solution Explorer over here. You have several code files open. Your model is your .cs files and your build file. But there's a whole lot going on when you're using this application. There's a whole lot of important states, such as which nodes of the tree view on the Explorer are expanded, what is selected, what document are you looking at, have you made changes to this document. All these things are state, important, significant state that is related to what the user is doing at that point in time. And it's these kinds of things that we try and push into a view model so that we can effectively pull the view off the top of the application and still test the entire functionality of the application, and we can then apply a lot of object-oriented programming tasks to the view model and decompose our entire application, make it much more extensible, much more maintainable over time. So that is the very quick model view model explanation, and we're moving on to the demo. And my computer went to sleep. All right, here we go. So what I'm going to do is I'm going to go ahead and just run the application that I built for this talk. And walk you through the basic features. And then we're going to spend the rest of the talk basically looking at code and seeing how some of this was implemented. Hopefully give you a set of ideas, maybe some new tools for your toolbox that you can take back and apply to your own projects. So what I built was a sample application that the idea is that I like to play video games, and I'm just going to track what games that I own and who I've got them loaned out to, right? And just a little bit of basic information. So I'll just take you through so you can see some of the features. I can start here by just searching for a game. I want you to pay very close attention to the state of the user interface. Notice the Go button is disabled until I start to type something in the search box. Notice the loading state that comes up as we hit the server to get back our results. We see we found 3 matches. I can go to one of them and I can sort of animate in. I can see the information. I rated the game. I can see when I added it to my library. I can say that I checked it out, loaned it out to my buddy Glenn. I can check it back in. Can navigate back to the search screen. I can search and see that I didn't find anything with that match. And this gives me a contextual view where I now have the option to create this if it's not already there. So I can go ahead and do that. If I go back, it notices that I have some unsaved changes. Again, this is really important in a real-world app. We don't want someone to just navigate back and then lose the data that they've edited. So I can decide to cancel that out and go ahead and add that game. Of course, I can add the game down here through this same interface. And if I have an exact match, I'm not only going to search, but I'm going to go directly to that detail page. Just noticing interesting issues of state. You've seen the loader that appears up there as we're loading. Notice the checkout button at the bottom is disabled because I haven't typed the name here. As soon as I begin to type, it enables. We demonstrated that with the search as well. Say I add a new game. So the title field is required. Notice that both the validation error pops up and the add button becomes disabled at the bottom, right? Until I go ahead and type to fulfill the minimum requirements in order to add the game. So this is just a basic run-through of some of the features. Also, let me show you one other thing that's kind of cool too. If I go to add a game and I try and close the window, that's actually a Silverlight 4 RC bug, I believe, but I'll show you how that works. It was going to display the same question dialog to make sure you didn't close the app without saving the data as well. We use the same mechanism. So that's just a run through the basic features of this sample application. I hope that you can kind of pair it in your mind with some of the more complex things that you might come across in a line of business app with dirty data, validation, navigation, different kinds of views of the same type of information, and so on and so forth. We're going to go ahead and we're going to start digging into the code. Let me just show you something real quick before we talk about the features that we're going to look at in the framework. If I open up the shell view, take a look at that for just a minute. There should be something a little bit striking to you right now if you have any Silverlight or WPF experience. I'll point it out in just a minute. I'm going to show you the code behind as well. Back to the view. Let me show you another one. This is the search view. Should be something hopefully jumping out at you, or you should see that there's something missing from this as well. So let's go ahead and talk about what I did with this little sample framework that we're going to look at. Go back to the slides real quick. The application code for this particular sample has absolutely no code behind, no event wire-ups, no commands, no data binding, no data templates, no async programming, no custom controls, and no third-party libraries. The goal of this framework was to get rid of as much of the goop of MVVM as possible, and to build a very small and compact framework that was specific to this application that would allow me as a developer to be able to move very, very quickly through my task of developing the application. The framework is under 500 lines of code that accomplishes this. All this will be up on my blog as well, the sample and the framework. I also wanted to make sure I didn't really use any custom controls or third-party libraries. I am using the Silverlight toolkit. That's the only real exception to that. I kind of think of that as part of Silverlight itself. And Normally, I don't actually suggest you go build your own framework, actually. But there are a lot of scenarios where you really need to do that. You can't use something that's already there. I come from Tallahassee, Florida. It's the capital of Florida, and there we have a lot of government work going on, and they can't use open source, right? So if you're working in that sort of environment, either government or your management won't let you do it, and you still want to try and gain some of the benefits, but you can't take a dependency on anything outside, that's the reason why you might want to go down this path. Another reason is that maybe you're building a really small and simple application. You can't really justify taking dependency on a larger framework or someone else's toolkit. You don't want to deal with the learning curve and so on and so forth. So then you might build your own framework as well. Again, this is a really small, simple framework. We're going to go ahead and walk through a couple of the features of the framework. Is anyone familiar with Caliburn? So that's my baby, basically. It is an open source framework for developing WPF and Silverlight applications. It's probably the most popular open source framework for WPF or Silverlight outside of Microsoft open source projects. If you're familiar with Caliburn, you're going to see some familiar things here today. What I did for this framework is I sort of took some of the things I learned in building Caliburn over the last 3 years, and I built a really compact, simple version of it. So this framework, again, is not designed to handle every edge case. It's not a generally reusable framework across all your applications you'll ever build, but it is an example of how you might build an application-specific framework for the project that you're working on, based and inspired on some of the work that I've done with Caliburn. So we're going to start by, and this is basically the outline for the rest of our talk, and this is the last slide you're going to see from here on out. We're going to be in the project itself, pretty much. So we're going to take a look at the bootstrapper that kind of gets everything going. We're going to spend a lot of time talking about convention over configuration, and this is where the real power comes from. For that, we've got a view locator service that knows how to find views based on a view model using conventions. And we've got a binder service that knows how to create all the data bindings for you, create the data templates, and hook up the actions. We're going to take a look at that. We've got a view model base class, which you can use to build your view models, which will implement iNotify property change and give you basic validation functionality. And then the last two, depending on how we're doing time-wise, I really want to get to coroutines because this is how we get rid of asynchronous programming. That's going to be a mind warp, but I think it'll be fun if we get there. And prior to that, the screen conductor pattern is a very simple implementation. This is what gives us that nag dialog when we try and navigate back. How do we know whether we can close this screen? How do we know when we can close the app? Really simple pattern implementation to do those sorts of things. So those are kind of the main features of the framework. It's under 500 lines of code. And let's go ahead and dig into it right now. Actually, that'll be over here. So we're going to start at the beginning of an application's lifecycle, basically, right in the app XAML CS. And again, I said there was no code behind. I sort of lied a little bit. This is the one code behind. If you know WPF or Silverlight, you really can't get away from it. And this is the one line of interest to us right now. So what we have to do is basically we have to bootstrap the framework. Before we can start our application, we've got to sort of do a little bit of management, kick off a few things, put a few things in places. What I've done is in the framework, I've encapsulated that inside of this bootstrapper class. And all it does is create the shell. So let's dig into that. This is a key component for us. Everything, by the way, is in this framework folder. This is actually going to outline a little bit of how the whole process works as we put together the application. The first two lines here, I'm not going to dig into the details of. There's a few extra goodies in this sample. When you download it, you'll be able to get a little bit more out of it than what I'm talking about here. But we're using MEF basically to componentize the entire application. So the first line up there just bootstraps MEF, gets it started up, makes sure it knows what our different components are, and puts all those into play. I went ahead and abstracted that into its own little class. The second line of code underneath that initializes an simple abstraction of our dispatcher. So what this enables us to do is to do some simple multi-threaded coding without actually having to take a dependency on the dispatcher class of Silverlight. So if we're testing our view models and we're doing things where we're pushing things to the UI thread and so forth inside of our view models, that's a real problem sometimes for testability because you then have to have a dispatcher in your unit test. So what we do here is I actually abstract it away very simply. I'm not going to dig into that, but you can see how that's done. That just makes things a little bit easier for us. Then what I do is I get an instance of the shell. And this is our first view model in the application. One of the interesting techniques I'm showing here is something I think of as hierarchical view models or fine-grained view models. So everything in this application from the very root all the way down to the little pieces that you see flipping in and out are all view models composed together at runtime. So the shell itself is a view model. In this case, I implemented an interface. It's very, very simple. It looks like this. You can open a screen in the shell. As you saw us animating to different screens, we were opening those, asking the shell to open those screens. We can ask the shell whether we can close it. So when you click the close button on the window, we can ask the shell, can we actually close you? And we can cancel out the close of the application. And of course, we can ask the shell or tell the shell that it's busy, and that's how we get that nice loading effect. So the shell exposes a very basic set of functionality to the other view models. We'll look at the implementation. It's very, very simple. I've tried to keep pretty much every class is under 100 lines of code. Every view is under 100 lines of XAML, pretty much. So everything is small and concise here. If you look at the shell view model, right here, you can see it implements that interface. We'll come back to the screen conductor. And it just has some very, very basic implementations. You're probably seeing something a little bit different here. We'll come back to that when we talk about coroutines. But it's a very, very simple class that basically conducts the other view models in our application. Let's go back to the bootstrapper, because we didn't finish walking through that. So we grab out that shell. That's our core view model that represents the application, if you will, as a whole. We then use this next service called a view locator. We pass in the shell and we say, well, shell, what are you supposed to look like? Tell us, view locator, what you're supposed to look like. It passes back a view that goes with that shell. We'll dig into that in just a second. Then now that we've got our view model and we say, view model binder, please connect these together for us. It goes off and does whatever that means. And then finally, we return that view back to our application. And it gets set as the root visual. Once it's set as the root visual, that actually starts out the composition of all of our other view models and their views. So that when we see the screens flipping in and out, those are just views that view models we're locating views for. We're plugging them in. It's all going through the shell. So once we bootstrap it, we're good to go. So let's dig into this view locator class here. I'm a little bit out of place without ReSharper on this machine, actually. Can't control click. All right. So the view locator is the first place that we're actually going to see an implementation of convention over configuration, right? So if you haven't heard that term before, a lot of frameworks and a lot of .NET requires you to do a lot of setup, a lot of configuration of the framework before it will do what you want. What we're doing is we're saying we don't want to do that. What we want to do is actually establish a simple set of conventions or rules for ourselves that we're going to use to pattern our application development. Typically, if you're architecting a solution, if there is an architecture to your solution, there are conventions, right? If you look across your solution and you see that there are no conventions or patterns across the software you're building, you've got a really big problem. So when we do convention over configuration, a lot of times what we do is we just go ahead and recognize the patterns that are already there, and instead of them being implicit in our architecture, we make them very explicit. Once we do that, we can then write a little bit of the framework code that understands those conventions, and then it can do work for us, so we don't have to do a lot of work. I don't have to manually, for example, create any of my views in this application. This class does it. And all it does, you can see very, very simply, if I scroll over, all it does is it gets the name, the type name of the view model, and it removes the word model from it, right? So if we had a class called let's see, shell view model, it would return a string called shell view, right? And if it was in a namespace, for example, like in this application called view models, the model part would also be removed, right? And we would end up with that. You can see that what we've chosen to do as part of our application architecture is to actually structure things just that way. So notice we've got our shell view model and our shell view, our search view model and our search view, and so on and so forth. So what we did is we took sort of a good practice that a lot of people follow when they're building MVVM style applications, and we standardized on it. We created a convention inside of our architecture, and now we're going to take advantage of what we were already doing anyways. So once we get the type name based on that simple convention, you can ignore this for the moment. We just ask the activator to instance that type, and now, boom, our view is created for us, simply by simple naming conventions. Again, if you've been doing MVVM, you've probably been following a naming pattern like this already. So all we did is turn it into convention and use that to our advantage so we can remove a little bit more of the glue code that we would normally have to write. So that's our first instance of convention over configuration. Very, very simple. You can see it didn't take much code at all to do that sort of thing. We just sort of looked at what we were already doing and then wrote a little code to do that work for us. This is where it gets interesting here. This is sort of the super magic, if you will, of this sample. Because now that we've found our view and we've got our view model, we want to put them together. So how do we do that without ReSharper? Sorry. And I should note, by the way, the model is faked for this application. I didn't build a real backend. All the loading that you're seeing is just sort of a background thread with a sleep on it. So we're not actually hitting the network. I didn't want to obscure everything by going and creating web services and doing all that, because the focus of this demo is the presentation tier. So there are some interesting things in there, but it's not a real web service call, just so you know. So in the framework, the view model binder is our second instance of convention over configuration. So what we did is we established a simple naming convention for our controls. And once we did that, we were actually able to do a whole lot of things. I want you to take a look at a specific instance of a view model and of a view before I dig into this code. If we go back to, let's say, that shell view, notice how we've named this busy indicator is busy. Notice how we've named this button back. Notice how we've named this transition content control active screen. So we've given meaning to the names of the controls. And if we look over here in our actual implementation of the shell view model, we see the isBusy property. We see a method called back. If I go to the base class screen conductor, you'll see a property called active screen. So what we did is we established a very, very simple convention for ourselves whereby we name the controls the same things as the methods and the properties on the view model, and the framework can actually put everything together for us. So let's see how we do that. We just start, this is our basic method bind here, so we just kind of start the workflow by looking, making sure it's a framework element. We do a little bit of reflection here. If you're not comfortable with reflection, this is going to be a real crash course for you. So .NET is great. We have a lot of metadata about all our types. So we're using that to our advantage here. So we're actually going to look at our view model. We're going to see what properties are actually living on that view model here. We're going to see what methods we have on that view model. Then we're going to go ahead and we're going to do some binding. So let me dig into this. We'll actually dig into the bind properties first. So what we do is we actually loop through all the properties on our view model. We do a simple find name on the view to see if we find a control that has the same name as the property. If not, we continue about our business. We don't really know what to do. If we do, we have a simple dictionary lookup that we do against that control's type to determine what the default or conventional property we should bind on is. So if we look up here, you can see where I've defined that very simply. All that I needed for this app. What we've said here is that if we find a text box, we probably want to bind to the text property. If we find that busy indicator, we probably want to bind to the isBusy property, and so on and so forth. You can see that I set these up as conventions. Just a simple pairing of control to dependency property. So once we've found a control and we've looked up to see what property we should bind, we then use the binding system to look and see whether we already have a data binding expression on that control for that property. Because if a designer or a developer had to put a specific binding expression in there, we don't want to override it, right? So the purpose of conventions is to get you there most of the time. But they're not going to get you there 100% of the time. You know, I constructed this sample app to actually get me there 100% of the time, but in the real world, you won't get there 100% of the time with conventions. So we always want to leave the ability to override, right? We always want to let the developer put in a more custom binding expression, or the designer to put a more custom one in. So what we do here is we make sure that we didn't actually have one there. And if we do, we just continue. We don't want to override it. If we don't, we're going to continue following our conventions. So this very, very simple logic here. We're going to actually create a binding in code. This may or may not be something you've done before, but you should know that the entire binding API can be done not only in XAML but in code. So we're instancing a binding here. The path for the binding is going to be the name of our property. Very, very simple, because we want to bind based on the control name to the property name. We're then going to automatically determine whether that binding should be two-way or not. If you worked with Silverlight, you know that this is a pain. Because in Silverlight, every property, every binding expression you want to be two-way, you have to explicitly set this in the binding. In WPF, that's not the case. It will default. So we're just going to say, I don't want to think about that, right? If it's a writable property, it's two-way. If it's not, it's one-way. We just established that as a convention for our view models. So we're automatically going to set the mode. The next thing we're going to do is we're going to determine whether we want to validate this property. This is also a convention that we established. We're going to go ahead and we're going to look at that property, and we're going to see whether there's any validation attributes on that property. If somebody put validation attributes on the property, chances are they want it to be validated. So we're going to turn validation on for the binding expression. So you can see these are very, very intuitive rules here. I hope this is all making sense to you. We can all determine this stuff at runtime. I'd be really surprised if there were validation attributes on this property and they didn't want to data bind it, right? So we're just trying to follow an intuitive set of rules here and let the framework do it for us. Next, I have a couple of special case rules, right? Again, if you work with WPF or Silverlight, you oftentimes have to bind a Boolean property to a visibility. So I actually just hard-coded that case in here as a convention. Anytime that I come across a Boolean property that is trying to bind to a visibility property, I'm automatically going to set a value converter that does that for me, right? Simple rule. You do it all the time manually. We're just going to let the framework do it for us. And then I just established another simple convention mostly for example purposes. But if the property I'm binding to is a date time, I'm going to establish a conventional format for all my date times. I'm going to make sure the binding has that as well. Finally, I set the binding on the control. And I apply a couple more fancy rules here. For my text box, the default behavior in Silverlight is that the text box won't push bindings until you've tabbed out of the control. I don't like that. I want it on every key press. So I'm going to hook that up. I'm going to make that my default behavior for my text box. Finally, I'm going to take it one step further, and I'm going to see whether I have an items control that I'm binding on. And if that items control does not have a member path, and actually you can't see the whole expression. Let me scroll over. If it does not have display member path and it does not have an item template, I'm going to generate a data template for it. And this is actually a little bit of data template kung fu. And I'll show you what that data template looks like. It's literally just a string here. That data template is only going to contain a content control. with a special attached property. That special attached property is designed to call back into the same bootstrapper type logic. So what we'll do is we'll actually look at the view model, we'll go locate a view, and we'll plug it in. So what we've actually enabled here is complete composition of our entire application because we can generate default data templates that essentially invoke our view location logic based on our conventions. So in Silverlight, you know you don't actually have data templates that will apply by type. This does that. But it actually applies it by naming conventions. And you could write your own conventions, of course, for your own app. So the view model attached property is one that I wrote. We'll take a look at that real quick. Just so you can see how it actually works. It's really, really simple. Just uses the services we already have. If I go down here to this view class, it's just a standard attached property with a changed event. Just look at what the changed event does. All it does is say, what view model did it actually change to? Go locate a view. Then go bind them. Then set the content. It assumes that it's a content control that this exists on. So that's an assumption for my framework that I'm building here. So this is actually how the entire user interface begins to compose itself, because every time we find an items control, we generate an items template that essentially invokes our view locator. This also does the same thing for content controls. Items controls, content controls by themselves. If we come back to the view model binder, you'll see that actually our default property for content control is my custom attached property. So every time we find a content control, we're going to essentially be invoking the view location logic on the model. Every time we find an items control, we're going to generate a data template that essentially puts a content control in there and invokes our custom view location logic. So this is how I can say on my slide there's no data templates, because the framework is generating a simple data template that actually calls back into itself to use our conventions to compose the UI. So this is a little bit, like I said, this is sort of your intermediate MVVM talk here. This is, a little bit of kung fu here with the data template generation. But I hope you can see that it's still relatively intuitive, right? Because we're looking at what the data context is of each item in our control, and we're still using the same set of conventions to find what that template really should be, ultimately. So that's how we bind our properties, and that's how we get away from doing any data binding at all. That actually works for this entire app. Like I said, if you had exceptions in your app, you would just write the binding expression, and we would ignore it. We wouldn't override it. The other thing that we do is we get rid of our commands. So we do the same thing we just did with properties. We do it with methods. We loop over our methods. We find a control with the same name as the method. If we don't find it, we continue about our business. Then we establish a secondary rule here. What we did is we said, if we actually find a control that matches a method name, let's look back at the view model again. And let's see if we find a property with the same name, but with the word can in front of it. So if we have a save method maybe, we're also going to look for a property called can save. And we're going to assume by convention that that does what it says and indicates whether that method can actually occur, right? So then what we do is we actually create a command on the fly. And I'll give you a little look at the reflective command, which is what I called it. Reflective command does probably what you would expect it to do. It takes in the instance of the view model, it takes in that method info, and it takes in the property info, which we may or may not have found, right? It's going to cast that view model as iNotify_property change. And if it is castable, and if we actually found a can execute property, we're going to go ahead and wire up the property changed. And anytime the can execute property changes, we're going to raise our can execute changed event on our command. Right here. It's a little bit of Lambda stuff here, so it may look a little bit strange. Our can execute is very simple. If we actually have found a property, we're going to go ahead and use reflection to invoke it and find out what its value is. Otherwise, we'll just return true. We'll assume it's always on. Execute, again, very, very simple. We're just going to invoke that method at runtime. And we'll dig into what we do with the return values a little bit later on if it has a return value. So once we create that reflective command, we're then going to just set the command, and we just do a little bit of cast checking, type checking, because there's only a few different types of classes we can set commands on. And we're just going to create the data binding expression again on the fly to our instance of the command. So this, now notice I don't have line numbers on this. This class is actually about 130 lines of code. So 130 lines of code to get rid of all your data binding expressions and all your relay command gook, right? Just establishing a very, very simple set of rules about how a view model and a view should intuitively be connected. So that's the view model binder. Now I told you that there's a couple other interesting pieces in this framework. We should probably let's actually just look at a couple of views and view models. We looked at the shell view. Again, now that we've seen how the binding works, you should be seeing the naming conventions here. Active screen, is busy, back. Let's look at the search view. Search text, execute search, add game, search results. Now, if we look at the search view model, search text, search results, this is important. We'll come back to that. Can execute search, this is our naming pattern, right? And execute search. So this method and this property get automatically bound to that control. And the execute search only works when search text is not null or empty, right? Skip over that. Add game and can close, which we'll come back to later. So just simple naming conventions, and we can put the entire thing together by a set of rules that you might have been following already and probably aren't too big of a stretch for you to start following if you wanted to. Let's look at the add game view model, because I said that one of the other things we have is a base class to support some of this. So our add game view model, notice it has that required attribute. So in this case, right, our conventions are actually going to turn validation on because reflection is going to tell us that's there. And we just have a few simple properties. This is all standard fair view model. We have the same naming pattern again, add game to add it to our library, and can add game. In this case, we can add the game if this model is valid. That's on the base class. We'll take a look at that. And then our can close logic, which we'll come back to in a little bit. So let's look at that base class for our view models. Again, we just took some repetitive code that we often write and pushed it down into a base class. We have to implement iNotify property changed. I'll show you how I did that. Very simple. I'm actually forcing it to always fire the event on the UI thread. Remember I said at the beginning I bootstrapped a little bit of stuff for our dispatcher, so I'm just piping it through that here. And then I also enabled strongly typed property change notification. If we go back to that same, let's see, 8 add game view model. Notice this is not a string, this is not a string, right? These are lambda expressions. So if I type something wrong, I'm going to have an error there, right? Which I don't get with a string. So you can kind of dig into how that works in the view model base. I won't go into it, but you can see that basically we convert the lambda expression into a string. So we don't have to type strings everywhere. This is one complaint people have about iNotify property change. The other complaint is that you have to do it at all. But we're just trying to make it easier on ourselves, especially for refactoring and ease of development. The other thing I included in this base class is an implementation of iDataErrorInfo. And again, we're just following some basic conventions here. We're just looking for the attributes. Anytime Silverlight calls into us and asks us for the validation message, we're going to use a little bit of reflection. based on what it's asking us for. And then we're going to use the built-in validation API to get back any errors on that property, and then we're going to either return a concatenation of all the errors for that property, or we're going to return null. So very, very simple. And for the error message, we're going to do the same thing, but we're going to do it for all the properties, right? Or for the entire object, basically. Our isValid property is, once again, built on top of that. It's isValid as long as there's no error, right? So very, very simple. Just a general base class for view models. And so you can see how our add game view model, which represents the screen that we're using for adding games to our library, just has the simple properties, the validation logic, which powers the base class, essentially. That can add game, which just passes through to our isValid property. So just a little bit of basic functionality in our view model base to make property change notification easier and to make validation very, very simple as well. Let me run the app again, now that you've seen a little bit of what's making this work, and let me talk a little bit about the structure in terms of what you see. So again, we have the shell. Remember we saw the shell view model and the shell view? That's basically everything from here up, and then there's a content control that conventionally binds to our active screen. Remember that active screen binding? Well, it so happens right now the active screen is our search screen. When I begin to type, that search screen also has a child view model, which it switches in and out based off of the search results. I'll show the code for that, just so you can get a high level of how all the pieces fit together. So remember that shell view model in the screen conductor, it had an active screen. In the case that we're looking at right now, the active screen is a search view model. And when we performed that search, we actually set this search results property to an instance of the results view model here, which has a message. You can see. And it has a list of results, which themselves are view models. Again, with our convention-based bindings, every time I say view model, there's a convention named view somewhere that's automatically getting composed into our user interface. So when we plop this, this results view model into our search results property, we're actually going to pull in the results view over here, which looks like this. And it has a conventionally named items control for results. And results is a list of individual result view model. And we're generating the data template for that items control. That's essentially for each one of these results, individual results view model is going to look up the individual result view. And it's going to plug that XAML in. So you can see how things are sort of being composed now based on our view model. So, and I haven't mentioned this before, but this is a view model first approach. You may hear people sort of debating view first versus view model first. I tend to favor view model first. I don't want to dig deeply into that discussion, but just for reference, so you know, this is a view model first approach where everything is being powered by the view model. A view is never created and then ask for a view model. I create a view model, and then we go find the view. So the view model is always in charge here. When we compose the view model, then we compose the view, rather than when we compose the view, then we compose the view model. So that's kind of a philosophical choice you have to make at some point. This is my way of doing it, and so you can see how that's, hopefully you can see how that's coming together. So what this allows me to do is create lots of fine-grained view models. You saw the search results view model, but also when we come up with something that we don't have a match for, we get an entirely different experience here with different contextual actions. Well, that's a different view model. So that's the no results view model. And notice that it has a contextual action as well. So we're just flipping that view model in instead of our results view model. And again, the views are composing themselves all together as a result. So let's go ahead and move on. We've got two other features. We're going to run through screen conductor really quickly. I mentioned that the shell was a screen conductor, so there's a basic class called screen conductor here that allows you to open screens. So when we show the search screen versus when we show the add game screen versus when we show the screen where we can loan the game out to a friend, the shell implements or inherits from this base class, and every time we're doing that, we're asking the shell to open the new screen, open the new screen, open this new screen. So all the screen conductor does is implement a little bit of basic logic for us. So essentially what it says is if the thing were, there's a couple of guard conditions at the beginning. We don't care if the thing you're passing in is null. If it's the same thing that's already the screen we're showing, we're not going to do anything, right? But the next thing we do is we look at the active screen and we ask the active screen, can you close? So that right now the user has clicked on that back button while they've already started to edit data. And we want to stop that. Right? Or at least we want to have the option to stop that. So we just implement a very, very simple interface called iScreen on each of our view models that just describes a very simple workflow for a screen, a very simple life cycle for a screen. And the screen conductor, or our shell in this case, is responsible for enforcing this life cycle. So every time we show a new screen, we're going to make sure it gets activated so they can do some custom logic in the screen. And every time we try and close a screen, because we're transitioning typically to another screen, we want to make sure we can first, right? So it's very, very simple. If we can't close the screen, then we just stop what we're doing, right? If we can, then we go ahead and we get the new screen, we activate it, we set it as the active screen, and we go ahead and raise the property changed. Because again, this screen conductor, it's all working on data binding. So that active screen property is bound to a content control, right? Which had that data template generated, which had the view location semantic. So you can see we're just doing lots of composition, very small view models, very small views. So the primary use case in this, or scenario for this, was that add game view model. And you can see it implements the iScreen interface. Doesn't really do anything on activate, doesn't need to, but the can close is really important. So it can only close if it was saved or if the user said OK for the message box, in that order, right? Otherwise, the screen conductor is not going to let you go back. If you click OK, or if it's saved, it will let you go back. So just very, very simple rules in order to get a little bit of basic workflow around our screens. A scenario that's very, very common, very, very typical in business applications. OK, we got 9 minutes and 40 seconds to do coroutines. So it's only 40 lines of code, all right? But it's gonna be a different way of thinking about things. So one of the problems that we have, especially in Silverlight, is that we've got web service calls that we do on the background thread, right? And then we've got to wire up some event as our callback. And this code gets extremely hard to read. And what happens if you've got a web service call you have to make? It's going to return a result. Then as a result of that, you have to make another web service call, and that's going to return a result. So you've got, you wired up for a completed event. Maybe you're using lambdas, and then inside of there you've wired up for another completed event. And looking at the code is ridiculous, right? It's hard to maintain, hard to read, hard to understand what's happening. Let me show you another way of doing it. Let's go into that search view model. Actually, yeah, we'll go into the search view model. So our basic logic when you execute a search is that we want to go out to the server. We want to look for games that sort of match the name that you typed in. If we don't find any, we want to show that not found view model, right? If we do find them, we want to show the results. If we find an exact match, we're going to go directly to the game, right? To the details page. Now you can imagine actually doing that with web service calls and callbacks could be kind of nasty, especially if we want to go exactly to the game, because The search results only returns a very small fragment. That's a result. That's a search result object, basically. That just gives us the name and the ID for our search list. It doesn't give us all the details. So if we do find a single result, we then have to go make another web service call to get all the details, right? So let's see how we do this in this sample application. And this is the mind bender right here. So the first thing we do is we create a query for our backend. I'm using a command query pattern for talking to the server. I'm not going to dig into that, but if you want to look at the fake backend, you'll see some interesting things there. We then convert that query into a special type of object that implements the iResult interface, which is part of this framework. And then we start doing some yields. And if you haven't seen this, C# 2.0 and beyond implemented enumerators. So what we're actually doing here is we're actually creating a list, if you will, or an enumeration of these iResult instances, which our framework understands. So the first result of this method is to show the busy indicator, right? And you've seen that pop up. The next is that we're going to actually yield our search to the back end, right? Now here's where it gets very interesting. This line of code happens synchronously. We show the busy indicator. This line of code happens asynchronously. And the next line of code does not execute until the callback occurs on the background thread and it's marshaled to the UI thread. I'm going to show you how this works in just a moment. Then you can see our workflow. And this is a lot easier to read than the equivalent of wiring up lots of completed events. Because then we basically have a sequential way of writing code that is asynchronous. So after we show our busy indicator, we make our call to the back end. We get the response back. If there are no results, we show the no results view model. If there's exactly one result and the title matches, we go ahead and make another call to the back end, asynchronously. Then when it completes, we go ahead and show our details screen. I created a simple little Fluent API for showing screens here. Can dig into that later. Otherwise, we're just going to show our results view model. And finally, we're going to turn off the busy indicator. So what we have here is a mixture of synchronous and asynchronous code written sequentially so that we can read it as a normal workflow. Let me show you the secret to this. 2 pieces. This interface. Everything that is yielded up from that action has an execute method and a completed event. The framework is going to call the execute and then stop yielding results from that enumerable until your result fires the completed event. So I don't know, that's 3 lines of code. The trick is in the special enumerator. Again, I can just about fit the whole thing on the screen here. All it does when we enumerate is, and on the first time through, we'll move next, right? So we're lazily evaluating that method. We're grabbing the first result that we come to. Here. We're wiring up for the completion, and then we're executing it. And it goes and does whatever it wants to do. We don't really care at this point. If it calls 5 web services, that's fine. It just has to tell us when it's done. When it's done, we're recursively calling back into ourselves here. We're casting the sender back as that iResult. We know it's a result. And we're unwiring the completed event. Then we're going to move to the next result, if there is one. Wire for its completed event. And then execute it. Now what happens here is the compiler generates a state machine for you every time you start doing these yields. So the compiler is keeping track of which line of code you're on before we actually yield the next result. So if we come back over here, when we start yielding, we actually execute, 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 yield, stop. until this fires this completed event. Then we pick up here, yield, stop, until that web service completes. Then we execute, and we execute, and we execute, depending on how we branch, right? Execute, 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 yield and stop. Yield and stop, execute, 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 yield and stop. So this is, you can go dig into this. This is kind of a simple implementation of what's called coroutines. It's not something that's natively part of .NET, but you can build it on top of iterators. And that's what we're doing here. Let's look at another example where this is used. We can also see this in the add game view model. Look at the bottom where we add the game. So again, simple workflow. When we add a game, we're going to, again, create an add game to library. That's a command to send to our backend. We're going to set this as was saved. This is yielding, right? It's still trying to yield the first result. So it's executing all that code, and then it stops there on yield, return, add. That calls the backend. And then it doesn't execute the next screen or the next line until that web service call completes. Then we show the screen. Okay? So this is a bit of a brain twister, but what this allows you to do is A, completely remove all asynchronous programming from your view models. Right? Because now you can write synchronous, it's much easier to read, and let the framework actually instantiate that enumerator and loop through and handle all the callbacks, etc. for you. The second thing it does is it actually transforms what would normally be an interaction scenario where you're going to have to mock out a service reference and test against that into a state-based scenario. Because we're no longer directly interacting with the backend. So look at this once again. I should have left it open. There's a call to the backend service here. But what we've done is we've sort of done it in a declarative fashion by yielding our add game to library class. So normally we would have to inject iBackend service into our view model, call that method, wire up the completed event, and then when we're unit testing it, we'd have to provide a mock of that service and do interaction testing. In this case, we don't have to do interaction testing. We can do state-based testing. All we do is yield, is enumerate this method, and check to see what it gives us, just like we're checking the elements of a collection. If it gives us an add game to library, we know it called the service. So we transformed interaction testing into state-based testing, which in my opinion is always good. I detest doing lots of mocking and interaction testing. So you can do this, again, the web services is a common scenario, but you can do this for any interaction. So we can create all kinds of iResults to do whatever. Play an animation, right? And then only execute the next line of code when the animation is completed, right? Call a web service, then play an animation, then call two more web services, then call an animation. And you can debate whether you want to execute an animation from inside a review model. But that's just an example of the kind of things you can do. Now, there's a lot of asynchronous stuff going there, but it'll read sequentially. Then you can test it using state-based testing. Just loop over the results and see what it's actually doing. Oh, it just yielded up a call backend server. Oh, it just yielded up a play animation. Check the properties on each of the results. Then you can write separate unit tests for your result implementations, right? So by using coroutines, we can actually, A, get rid of asynchronous code, 2, transform interaction scenarios into state-based scenarios. I should show you an implementation of one of those results. That is actually our back-end call. So we have a query result. This is where we're querying the back-end. See, it just implements that interface. All it does is get an instance of our service, send a message to it, wire up a callback, and then whenever the service is done, we raise our completed event. So this is, because I followed actually a command query separation pattern for the back-end communication, this is how I do all queries to the back-end. Very, very simple, very little code. How do the enumerators actually get executed? Well, we started by looking at convention over configuration. One of the powerful things that we did is we usurped the execution of all our actions, right? We created that reflective command. Remember that? That's the thing that actually executes all our methods. So because we actually took control of invocation, we now have tremendous power to add a lot of features conventionally, such as here, we get that return value, and we look to see what it is. And if you actually return an I result, we'll convert that into an enumerable, right? And if it's an enumerable, we'll create our enumerator, and we'll just enumerate it. Because we control invocation of the method through this special command, we can now add coroutines to the action. But we don't have to stop there. I stopped for the purpose of this example, but once you control invocation, you can now add automatic exception handling. You can now automatically asynchronously execute any method that you want. Say you want to establish a convention that's anytime the action ends with the word async, you want to new up queue a background thread to execute it, right? So you could establish that convention. You want to go ahead and do that real quick? I can see it in your eyes. So what we can actually do here, I'm debugging. So we can do let's see, if. I was really trying not to write code during the talk, but I failed. So we just established a new convention, right? Because we control invocation. Oh, shoot, I don't have a resharper. There we go. Well, I'm not going to fully factor this, but I'm going to do a little bit of copy-paste here. Hope you'll forgive me. Done. Right? So conventions are really powerful, but what I'm trying to show you here also is that once we implement one of these conventions, we can then start to build and build and build as we need it. If I want to implement automatic exception handling, we'll do it down here. I'd have to do it in both places. Okay, how about that? Now every action that we perform will be wrapped in a try-catch automatic. Let's establish another convention, shall we? Let's go ahead and get our execute method. Let's see what the declaring type is. Let's get a method. Let's say that we want to establish a convention that anytime an exception happens, we're going to look for a method called onError on our view model. And if we find it, we're going to pass the exception into that method and let it handle specifically the exception. Otherwise, we'll have a general handler. We'll do some logging. Oh, by the way, we can now add logging to every action, right? So this is a decorator pattern, but it happens in the context of the command, right? And we're using conventions in combination with that. So we can build and build and build and build and build lots of interesting things. The point of this is that it's all infrastructure code. You shouldn't be writing this in your view model. It gets really, really, really tedious doing that. We should be able to just have simple properties, simple methods on our view model. We should be able to see the things we're interested in there, and we should not have to see these kinds of things. So I hope that this gives you some tools for yourself there. Again, this framework was developed for the sample application that I wrote for this talk, right? But you should have some ideas, I hope, about what you can do for your own applications. Let's go back to this. There's really not much more. As I mentioned earlier, I actually have a framework that is a general purpose framework. It does everything I showed you here. Like I said, all these features were inspired by things that Caliburn actually does, and it handles a lot more edge cases and does a lot more fancy stuff. It does do exception handling, async, conventions, view location, all that kind of stuff. So you can check that out. If you can't use it, for whatever reason, build your own, right? Don't get stuck writing I notify property change over and over again. Don't get stuck creating relay commands over and over and over again, right? That's stuff that you really don't need to do. So check the framework out. My company, Blue Spire. You can hit up my blog on Devlicious. This code will be posted there in full, hopefully by the end of the day. And we're definitely out of time, but we're at the end, so I guess we could take questions, right? Fill out your evals. There's microphones here, 2 microphones. If you have a question, if you don't mind going to the mics so people can hear you. There's at least one question I expect people to ask that I haven't addressed yet. I'm hoping someone will ask it. Yep, so the performance of reflection. The biggest problems with reflection and performance is when you're doing it in a loop, right? You probably didn't really notice that everything was happening with reflection until I showed it to you. So again, also the power of conventions is that you can use them out of the box to get, your functionality, and then you can come back to a single screen and say, this screen is not performing the way I want it to. Let me get rid of the conventions here, and let me be very explicit about how I want to do things. So again, the conventions in this mechanism is designed to take you maybe like 80% of the way there, and then for those specific cases, you want to optimize. I don't think you'll notice it most of the time because, again, there's not tons and tons of reflection. With the conventions, you can take it a step further and actually cache the information you discover about the view-view model relationships. Then you don't have to run those rules every time. Like if you're displaying the same view over and over again against the same view model. Right now, this implementation is running the same rule checks over and over again. You could go ahead and cache them, and then would speed that up, right? And if it's really painful, you just turn off the conventions, create your own bindings, create your own wire-ups. Again, the framework ignores all that kind of stuff. You could very simply create, say, an attached property for the view that would say, don't even bother looking at this view for conventions, and it would skip over it. So you could do some things like that if you find it's a problem. I don't think you'll find it's a problem in most cases. Any other questions?
How do you handle visual state?
Handle which state?
Visual state.
Oh, visual state. Again, you could, how do I handle it? Well, a simple pattern you can do is create an attached property and then again, just create that state binding between your view model and your visual states. You could probably establish a convention. Say you have a property on your model called state. Maybe it represents a visual state, so you'll go ahead and create those data bindings automatically to the visual state manager. So you could do something like that if you wanted to follow the convention-based approach. Nobody wants to ask about how this works in Blend? Okay, let me answer that question. Glad you asked. So this technique is actually optimal for a developer-centric shop. So I imagine there's a lot of you guys that don't have designers out there. You're just pumping out line-of-business applications. The problem is when you do these conventions, Blend doesn't understand that, right? So you open up Blend and you try and put some sample data in there, you're not going to see anything, right? Because the data bindings don't exist. There are ways around that. A couple of thoughts I have on that are one workflow that we use, for example, is that I'll oftentimes build view models and stub out views very, very quickly, and then I'll pass it off to somebody else who's going to actually style the views and create the feel or the look of that view. So me as a developer, if I'm coming first ahead of him, I'll take full advantage of all the conventions, and I won't worry anything about that. When he comes in with Blend, he can go ahead and add the binding expressions. So we didn't actually lose anything there. As a developer, I actually was able to get my job done quicker because I didn't have to worry about it. And then he, as a designer, can actually go ahead and add those back in later if he wants them to see sample data. Another thing is you actually don't have to use sample data at all. You can go ahead and he can go ahead and put the sample data values in line if he wants. So if he wants to see what the text box looks like with Rob Eisenberg's name in it, he can go put it in there. At runtime, we're going to override it with the actual binding, right? So he can go ahead and just put the sample data values in there the same way he sets any other value. And then if it happens to meet a convention at runtime, we're going to replace his value with the actual data binding based on our conventions. So that's another thing as well. I will say also that one thing about Caliburn that I'm working on is I prototyped and I'm going to build a mechanism that allows full convention-based view composition and data binding inside a blend. It's not done yet, but it will be coming. So it's very difficult to write that when you build your own framework, so you have to know whether this sort of thing works for your own workflow, know some different workarounds, and whether that's going to make sense for you. With Caliburn, it's more of a framework, so I can actually go ahead and solve that problem for you. So hopefully in the next couple months, you're going to see a drop of that where any conventions that you define, any view locator rules that you define will automatically be accounted for inside of Blend at design time. So with sample data working and everything. I just haven't done it yet, but I prototyped it, so I know it works. Any other questions?
RIA services? How does this work with RIA services?
It works.
In the sense, because the models are being extracted and generated, the code is being generated, so would you have to modify the code so that your base classes come in?
So if you're using a RIA service class to play multiple roles, in other words, if you're using it as a view model and a view model, you just need to be aware that you may hit some walls with that. Generally speaking, though, the reflection and the checking for attributes and things that I'm doing, it shouldn't really matter. And I didn't actually show this, but one of the views that you saw was actually not a view model class, it was a DTO. If you remember way back at the beginning, I showed the view locator and I showed this special if case in the middle, and I said don't worry about that. It was a secondary rule that it looked for a naming convention, or it could be a namespace, and automatically mapped views over for my DTOs. So you could have view models that follow that naming convention, and you could have views for them, and then you could set up a secondary location convention where you said, if it comes out of a namespace that is classes generated by RIA, I actually have views for these guys, and they're over here. And once you find the view, the same data binding patterns can work. The validation will kick in, the two-way versus one-way will kick in, all that same rules. So you just need to maybe add a special case to that convention, or convention about where you're going to locate views for classes that are not view models. Anything else? Yeah.
The bugaboo, if it's not click on a button base, right? I mean, if it doesn't have iCommand.
Right.
So is there some way to extend this, or am I going to run into problems with behaviors, or however I'm doing that?
Well, Caliburn handles everything. So, but just establish another convention, right? So we had a lookup of control to property that we were going to data bind. So create a lookup of control to event, right? And then if it doesn't implement iCommand, go dynamically wire up the event. And when that event occurs, just go ahead and you can still use that reflective command internally to do the can execute and the execute and so on and so forth. So you can extend it that way. I didn't go that far here, but just establish conventions about, if it's a checkbox is a button base, so that doesn't matter. But if it's a list box, it's going to be the selection changed or whatever event. And that's your convention about control to event. So you can extend it that way. Yeah. You can, just all the patterns, just think of what you do, over and over again. Most of the time you're wiring the selection change event. Most of the time you're binding to this property. Go ahead and create rules around that and then alleviate the need to do all that manually every single time. Can you go to the mic? Do you mind? Oh, if you go ahead and yell it out, I guess, too, if you want.
Yeah, specifically for mapping between a view and a view model,
Mm-hmm.
have you thought about cases where it's not a one-for-one?
Yep, I have. Again, this simple framework doesn't really handle that. The way we do it in Caliburn is that we have the idea of contextual views. So we can have multiple views over the same view model, and our view model locator, our view locator, actually says, oh, we've got this view model and we're showing it in this context. Here's how we find the view. And we do that by subfolders, you know, and things like that. You could establish a similar convention as well. So for example, you could say, like, I'm going to look at the name of the control that we're hosting the view within, and I'm going to go look for a view that is some combination of that name and the original type name or something like that in a certain place. So you could establish a set of conventions that would allow you to then have multiple views over the same view model. Anything else? Yeah.
How would you combine, like for example, the tab control,
Uh-huh.
where you have lots of views?
I would we use something like a screen conductor, but I would also have a collection of screens and track the active screen. And I would bind the item source to the collection, and I bind the current or selected tab or whatever to the active screen. And that way I can actually control it from the model side that way. I can also establish the same sort of conventions for the selector as I did for the items control, where I automatically know how to contextually locate what view should be inside of the tab and what view should be inside of the content area. So maybe a naming convention, right? So you could do all that kind of stuff. Caliburn actually does that, but that's how I know the answer. Ward, oh, nice shirt, man.
Thank you, man. Great talk. I love this stuff, but one of the things that people talk to me about when they see deeply composed views is the challenge of seeing the views during their design time, and you know, particularly if they aspire to use blend. What can you tell people about that?
So I kind of addressed that a little bit earlier with the design time support for the binding. It's the same kind of issue. I am solving it for Caliburn, where we'll be able to compose the views. You could establish, say, you know, you can actually execute code inside while blend is running. So you could theoretically actually, and this is what I plan to do for Caliburn, you could theoretically actually execute your view location at design time and pull it right in there. Actually, I haven't even tried it, to be honest. But you could probably write a little bit more code and maybe get that to work. Then, for example, you could open up the shell or something like that and actually see a little bit more composed. There's always going to be certain parts that are dynamic by nature. So you would have to have some default view, maybe convention of what to plop in there for design time.
But if you had perhaps test-oriented or design time-oriented view models or some kind of switch, then they could behave rather than flying off to wherever they go to get data, and it might feel like you were seeing the whole thing. Could it be something like that?
Yeah. And again, I flew past this, but this also uses MEF. So if you guys get a chance to look at the code base, everything is composed together with MEF. I didn't implement interfaces necessarily, but I could implement interfaces across view models and actually plug in different things at design time to the container instead and do, if you saw Lawrence talk, he kind of showed that kind of thing too. So that could all play together in the same kind of solution there. Yeah. So hopefully you just have some ideas about some different little tools in your toolbox and different things, looking at what you're already doing and trying to actually take the implicit rules and make them very explicit as part of your architecture. Again, it's not going to take you 100% of the way, so if you come across this scenario and you say, well, how do I do this? If you don't come up with an answer, that's not a big deal, right? Because you can always fall back to the explicit way of doing that. But you want to try and get rid of, you know, a good percentage of your most common scenarios. So. All right, that's it.